Hello everyone, this is Shalini Sheetal from Shecoders in ITR, and today we are going to cover the second topic in our series of Python tutorials, namely data types. We shall be deeply exploring the various kinds of data types present in Python. So let us begin today's session by first knowing the meaning of data types. What are data types? Data types basically tell a computer system as how to interpret the value of a variable. You must be familiar with different data types like int, float, char, etc. in C and C++. So let us take this discussion quite further, beginning with strings. So I have laid out the entire format of today's session and I shall be sharing it with you guys via GitHub. So strings. Strings have various properties in Python, some of which are specifically that strings are immutable. What that means is we cannot change the data at the same location. If we try to modify the string, then its location will be changed as well. This can be understood well by first taking an example of a string. We declare s as hello Python. This is how we declare a string either within single quotes or within double quotes. Anything would be fine. And we then check its ID. Here it is 15987, whatever it is, but it has a certain ID assigned to the string. Next, we define the same string as a quite different string. We take it as hello world from Python. And then when we check its ID, it changes to something different, right? As you can clearly see, both these IDs are very, very different. So the next property that strings follow are that strings are iterable. What iterable means is that we can traverse a string in a particular sequence in a particular order. So if we want to print a string, either we can directly write print s or we can mention it with an asterisk. Now what this asterisk will do is that it will traverse each element, each character of a string bit by bit, and since the default separation in Python is a space, a single space is assigned within each character of the string. So the string was earlier hello world from Python, but since we now traverse it using an asterisk, telling the interpreter that it is an iterable, a single space is assigned between each of the character of the string. If we explicitly mention the separation as just a blank space with no blank space at all, then hello Python is printed. Since we have taken the string as hello Python, yeah. So the output here, as you can see, is hello world from Python. If we explicitly define the separation to be nothing, it is not a space, it is not a blank space, it is nothing, null character, right? Nextly, the third property of strings is that they are subscriptable. You must be familiar with array indexing. Arrays are known to be subscriptable. Each array has a subscript assigned to it, so we can access each element from its index location. The same goes with string as well. Suppose we write s of 0 within square brackets, we assign the index, then since the first character is h, remember indexing begins from 0 and not from 1 in Python. So we begin from 0 and since the first character is h, the output is obtained as h. We can access any character by using its index value provided it is not out of bounds, that is it should not be greater than the maximum number of characters present in the string. So suppose we take it as s of 10, then it gives the output as d. Nextly, the interesting phenomena in Python is that an array or a list or a string is that can be accessed backwards as well. We can follow backward indexing, which is not supported by many other languages. So suppose we write s of -1, then it is given as n, which is the last character in our string. The string is hello world from Python and n is the last character, so we obtain the last character as n. So Python follows backward indexing as well. You can also write -10, but remember there is nothing as -0. Backward indexing begins with minus of 1, whereas forward indexing begins with 0. So remember, we can also access a string or a list or an array in Python backwards as well by using a negative index value. Now let us become familiar with some of the common functions in strings. The firstly we see here is s.upper. The upper function converts the entire string to capital format. So each character is converted to its capital format and it gives the resultant string as the output. Now, as you can see, uh, first the ID of S was something different, right? Here we had the ID of SS744, but suppose we now convert it into S dot upper and then we check its ID, then it is different again. This again proves that strings are immutable. If we do any change to the same string, then its ID changes, implying that its location, its value is no more the same, it is a different string now. So strings are immutable. It is a very important point, so keep this in mind. Similarly, we have the opposite function of lower as well, which converts the entire string to its non-capital form, to its lowercase. There is also a function called capitalize, which capitalizes the first character of the string, not of each word, but rather the entire string. So only H is capitalized, and the rest of these letters are in lowercase. We also have a title function in Python which converts each character, each first character of each word in a string to its uppercase. So as you can see, each word here, the first letter is capitalized. H for hello, W for world, from, F and Python, P. So each character is capitalized in title function. There are actually many other functions as well. For example, we have the isAlpha function. We can demonstrate that here. Suppose we take a string as hello from shecoders. So if then we check that it is an alpha or not, is alpha, then it gives the output as false. Why is that so? Since we have blank spaces as well. Now suppose we remove the blank spaces and then check the same, it turns to true because it now consists only of alphabets. So it is purely an alpha string and the output is given as true. There are other functions as well. For example, if you take x as a digit and then check if it is a digit or not. I'm sorry. It gives us true. Since 9 is a digit, if you convert it into something different and check, then it gives false since it has A, and A is an alphabet, not a digit. So provided we give a digit to its input, it will give the output as true. There are others as well to check if the function string is lower or not. You can check it with is lower or is upper, and there is an interesting function in Python which can be used to check if a word can be used as an identifier or not. Suppose S is hello from she coders and we check that it is an identifier or not, and it gives us true. That means you can use this string as an identifier in Python. So any variable, if you have a confusion that if you can allot it as a variable name or not, you can check it using the isIdentifier function. Another is you can also find the index of a character in a string using the index function. For example, s.index, you want to know the position of E, then it gives us 1. As you can clearly see, E here is present as the first character, I mean the second, but if we follow the indexing, then it is at position 1. It is the second character present at index 1. Suppose you want to know the position of index of E from the right side, then instead of I, you can just use R index and it will give you as 15, which is this position here, right? This E. So there are various functions related to strings and you can explore more on them and know more about them. Nextly, we come into partition. Partition is a function in strings or in Python which take an argument as a string and then partition that particular string into three parts, exactly three parts, which is the left side of the argument, then the argument itself, which the character you have passed, and then the right side of the argument. For example, S here is hello world from Python, right? Suppose we partition it at position F, then F is present here. So the tuple is returned as hello world with a space here as well, which is the entire string before F in the string, and then F itself, which is the argument passed to the function partition, and then the rest of the string, which is present at the right hand side of the argument. Similarly, you can do it for P as well. The entire string before P is returned as the first element in the tuple, then P is the second element, and the rest of the string is the third element. Similarly, if we check for O, there are two O's in the string. So what output do you expect? Python by default will partition the string at the first O it encounters. It will traverse the string from left to right, and as soon as it encounters an O, which is the O for hello here, it will partition the string right there before and it will not check if any other O's are present in the string. So in this case, we obtain L as the first element, the tuple, then O itself, and the rest of the element here. Python doesn't care if there are any other O's present in the string afterwards. It partitions the string in the first O itself. Now what if we want to partition from the right side? What if we don't want to take the first O and want to take the last O instead? So in that case, similarly for index, you can use the R partition in this case, indicating that we want the partition from the right hand side. And in this case, you see the partition is from the right hand side. The last element is N, which is after the last O, and the rest of the string is obtained as the first element here. Now remember that partition is case sensitive. Suppose we want to partition at H, it is not going to split at the first H here. It will search for a lowercase h, which it obtains in word Python, and then the partition occurs. Now suppose we partition at capital H, then since there are no characters before the capital H in the string, we obtain a null value and then the capital H, and which is the argument, and then the rest of the string as the third element in the Python. Now what do you expect if the argument is not present in the string? Then in that case, it will traverse the string from left to right. It will realize that the character is not present. So the entire string, since it is already traversed, is obtained as the first element in the tuple. Then the second element is null, since we didn't find the argument, and the last element in the tuple is null as well, since we have nothing after the argument in the string. So you can also explore more in these cases and see for yourself at what different cases are possible for this partition function. Nextly, we describe a similar function to partition, which is split. But the difference here is that there is a default argument in this case. If you just leave the partition in this case as empty, then it will return an error. Suppose s.partition. As you can see, it takes exactly one argument and we have provided it with 0 arguments, so it is going to return an error here. So you must provide the partition function with an argument, otherwise it will return an error. But with split, you can keep the argument as null, and it will by default will take it as a space. Now partition return a tuple. We will cover tuples later on, but as you can see, there are round brackets here which indicate a tuple. But split function returns a list. Square brackets indicate a list. So as you can clearly see, the split function returns a list here. Keep this in mind. And lastly, partition always used to split the string into exactly three parts: the part before the argument, then the argument itself, and then the rest of the string which used to come after the argument. But it is not the case with split. In case of split, it can return any number of strings, to be precise. It does not return the argument itself. Suppose we split it at f. As you can see, f is not returned in this case. It just returns two elements in a list, which is the string before f and then the string after f. Now for O, we had seen that there was some confusion. We had to follow partition, R partition, in order to split at different positions. But with split function, you can just pass on the argument as O and it will split the string at every O it encounters. There are no O's returned, but as you can see, this function is split at every position of O. There are three O's, and hell is the first word before the first O. Then we get another W with a space, and then the RLDFR, and there is another O here. So we split it again there, and as many O's are encountered, four O's are encountered, and the function splits the string into that many parts as well. Now if there is the argument is not present in the string, then it will return a list with just one element, which is the entire string itself. As you can see here, we haven't passed any argument here, and by default it takes the argument as space. So since there is a space here after every word, Python splits it up into four words in a list, which are hello world from Python. There are no spaces, the string is split at every space, and as a result four words in a list are obtained. Now another function here is strip. Strip is used to remove any trailing characters we want to remove in a string. Mostly they are used for empty spaces, so that we can remove the spaces and realize that what the user wants is just hey there, and that the spaces are unnecessary. So suppose we declare A as hey there, and as you can see there is a space in the beginning as well as in the end. So if we do a.strip, as you can see in the output, no trailing spaces are found. In this case as well, the default argument is a space, so it removes any trailing spaces or leading spaces. The next thing here is we had it as hello world from Python. Now suppose we want to strip any different characters. We don't want the spaces to be removed, we want some different characters. Then you can explicitly pass on the characters as the argument, and it will remove the required characters from the ending or beginning of the string. We have passed n here. There is no n in the beginning, so it doesn't do anything in the beginning, but since we encountered an n in the end, it removes that particular character from the end and returns the required output here. Now as you can see, I have taken lots and lots of just spaces here and then use the strip function, and what it does that it removes all the spaces as of which we have nothing left, and it just removes a null character, null value with nothing in between quotes. Nextly we come into join. The general syntax is given here. We first mention the element we want to insert in between the string, and then we use the join function and then give the string in which we want to insert it. So here we have explicitly mentioned that we want to insert the star symbol in between hello, and you can see the star is inserted between each and every character in the string. You can also just give a space, and since this is just a space, you just obtain the output with spaces in between each character of the string. Now remember that the element in between the parenthesis here must be iterable, which means that it must be a string or a list or a tuple. You just can't pass on a digit here. If if you pass on a digit, since they are not iterables, you cannot just write space dot join 1 2 3 4 5. This is not acceptable. It must be an iterable. Since numbers are not iterable, you cannot traverse like that. But if you put them within quotes and then obtain the output, it won't give you any error, since this is again an iterable. A string is an iterable. Next, we cover a concept which is quite important, which would be of huge use later on, and it is slicing. Now, what exactly is slicing? You cut fruits, you cut vegetables into slices. It is basically dividing something into parts. According to the width you want, you can cut broad slices or narrow ones. It is completely up to you. So, there is a similar concept in Python as well. And for example, this is the general format. The first one is the starting index, the second one specifies the ending index, and the last one is the step. So here we begin from the index 1 character, go on till the 6th. Remember, slicing, if you mention it as 6 as the ending character, then it will stop at index 5, meaning that the 6th index won't be included. Everything up till the 5th index would be included, and that would be printed as the result, but the 6th index would be excluded. And we have mentioned this step as 1, so it traverses each character up till here. Namely, 5 characters are covered and the output is given as hello with the space. So what if we don't mention this step? Then by default Python takes it as 1. We have omitted the step here, but the output, as you can clearly see, is still the same. Now in this case we have taken the step as 2, and you can see one L is skipped, the O is skipped as well, and the rest of the alternate characters are printed. Now in slicing, you can also give the step as backwards, but remember the direction must comply with the step you have given. Since here we want Python to move from 1 to 6, which is in left to right direction, but -2 clearly implies a negative direction, right? On the number line, minus means from right to left. From 0 to you are moving to -1, -2, which is from right to left. So the directions are opposite here. So if you want Python to perform slicing in a backward direction, then the steps as well as the indexes must be in the backward direction as well. We reverse the indexes, the beginning index is 6, the ending index is 1, and then we mention the step as -2, then it will give the required output in the reverse direction. Now what if we don't give any arguments, we just leave a colon and leave it empty? Then in that case it will print the entire string, since it will understand that you want the slicing to be performed from the first index right until the last index with the default step value of 1. For example, if you want to reverse the string, then slicing can be quite helpful. Don't mention the ending and space starting characters. The Python will understand automatically, and since the step is explicitly defined as -1, it will reverse the order and print the string from last character to first character. So similarly, if you want to print the first 5 characters, in that case as well, you can skip the first character. Python will understand that you want the output to be printed right from the first character up till 5. Suppose the last 5 characters in a similar fashion, you omit the ending character. Python will understand that you want to print the characters beginning from the character at position -5, which is the 5th character from last, up till the first character. Since we have omitted this step here as well, Python will take the default value of 1. Nextly, we come to another data type which has a vast use in Python, which is lists. Lists and strings are something which you will encounter very frequently. Tuples and sets are not used as much, but lists and strings have a vast use in Python. So lists are something which are used to store multiple items in a single variable. That sounds similar to arrays, right? But there is a catch here. In lists, you can store elements of different data types together as well. For example, a single list can contain integers, floats, strings, characters, etc. etc. Everything can be accommodated within a single variable of list type. Now, let us explore some of the. As you can see, we have taken a list as 1, 2, 3, 4, 5, and if we check its type, then Python gives the output as list. The first thing we see here is that they are mutable, which is the opposite of immutable, indicating that if we make changes to a list, then its ID doesn't change, it still remains the same. The list first here is 1, 2, 3, 4, 5. Its ID is printed here. Now we change the list to something different. We append a few strings to it and then check its ID, and as you can clearly see, its ID is still the same. So in lists, even if you make any changes to the list, its ID is not going to change, so they are mutable. Now you can another thing is that they are iterable. You can print it directly by just writing print L, but if you want to omit the square brackets, insert some space or some tabs or end lines with it, then you can print it similar to a string using an asterisk. For example, we have put the asterisk here, explicitly mentioned the space to be tab, and as you can see, a tab is inserted between each and every element of the list, and then the list is printed, omitting the square brackets. The next point here is that they are subscriptable. Lists are subscriptable as well. We can access list elements by using an index value. For example, the first element here is 1. So L of 0 is 1. The output is obtained as 1. Python supports backward indexing, so L of -1 would be the last element in the list, which is the string she/coders. Now, similar to strings, lists also follow slicing. So if you want to print the elements from the character element at index 1 up till 6, so you can also write L 1:6 and it will print the required elements. Similarly, to reverse a list, you can follow the earlier syntax which I have mentioned in case of strings, and it will print the elements in the reverse order. It is similar if you see that if we follow the L.reverse function, which is a function provided by Python to reverse a list, the output is same, right? So we don't want the reversed out list, so we reverse it again to obtain the original list that we had. And now let's get familiar with some of the other functions that Python provides for lists. They come in quite handy. Suppose you want to insert an element in a list at the end. So you can use the append function, and anything you pass it on as the argument will be added to the end of the list. We have appended high here, and as you can clearly see, the list now has high. Similar to the append function, if you want to perform the opposite, which is delete an element from the list, you can use the pop function and it will delete the last element which was added to the list. Any element which would be present at the last index would be deleted. You can pass on a particular argument in the pop function as well. Suppose you pass the index value, this is the index value in the pop function, then the element at index 1 is deleted, which is 2 here, and the element which is deleted is given as the output, and as you can now clearly see, the list does not contain 2 anymore. The element at index 1 is deleted permanently. Now suppose what if you want to insert an element at a particular index value? In that case, you can use the insert function. The first argument here would be the index you want to insert the element at, and the second argument in the function is the element which you want to insert. So we want to insert by at index 2, and as you can clearly see, by is appended. Not appended, rather inserted. Appended means added to the end. So we explicitly define the index position and then we pass on the element we want to insert. Now, lists also have a sort function, but if you use the sort function in this list, which has both integers and strings as its elements, there will be an error. How can you compare integers and strings and then arrange them in some particular orders? So if you want to sort a list in a particular order, then remember that its data types must be the same. All its elements must have the same data type. So suppose you take another list as a collection of random numbers, random integers, and then you sort it out and then print it. As you can see, the list is now sorted in order. It is in ascending order, but if you want to convert it to descending, then within the sort arguments you can pass reverse is equal to true and it will sort the array in reverse order, namely descending order. There are some tiny other functions that lists possesses. There is the len function, which implies length. So it will return the number of elements present in the list. Here it has 7 elements. L was 1, 3, by 4, 5 Python C coders. There are 7 elements, so the length of list is returned as 7. There is the max function. Again, remember to find out the maximum of something. In order to compare something, all its data types must be same. So again, you need to use the max function on L1, which has just integers as its elements. So in that case, the maximum value is 100 and it is returned as 100. Similarly, you can use the min function to find out that the minimum value present in the list is 10. Nextly, we perform addition on list. What do you expect if we use the add operand? Then if you use L1 as 1, 2, 3, 4 and L2 as 5, 6, 7, 8 and then use the add operator, as you can clearly see, both the lists are just appended to one another. L2 is appended at the end of L1 and they are merged into a single whole list. So this is what addition operator does to the lists if they are added. Now there are many functions actually assigned to lists. If you want to know more about them, then you can print the directory of the list. And this will give you the list of every function present in list. We have covered many like sort, reverse, pop, insert. So you can use them and check what each of them does. And if you get stuck anywhere, you can use the help function to find out its use. You can always refer to the documentation if you have any doubts. Nextly, we come into another data type, which is tuple. We have come across tuple up quite earlier. Anything within parentheses is a tuple. It is also a collection of similar and different data types. It is iterable, subscriptable, but it is immutable. Unlike lists, we cannot change the tuple without changing its ID or identification. The tuples are immutable. So suppose there is a tuple as follows. We find out its type in Python and it will give us a tuple. Since they are iterable, we can traverse them using an asterisk and the required output is obtained as well. If they are subscriptable, so we can also access the tuple values using indices, and t of 0 would give return the first element in the tuple, which is 10 here. Since they follow indexing, we can also slice them, right? So tuples also follow slicing and you can put in the required indices, the required step values and obtain the tuple you require. Now the most important point here which makes them different from lists is that they are immutable. So we cannot add or remove something without changing the identification of that particular tuple. We cannot append something to it, we cannot pop or remove something from it. If we do so, its identification would be changed. So what usually is done is that if we want to make changes to a tuple, then we first convert it into a list, then append or remove the required element from the list and then convert it back into tuple. So we have done the same here. We have first converted the tuple to a list, then appended what we want to append, for example 100, and then converted it back into a tuple. Now as you can see, we obtain the output as a tuple now with 100 appended at the end of the tuple. Next we can come into another data type which are sets. Now sets are collection of specifically immutable data types. which means that you cannot put in mutable data types in between them. We have seen strings are immutable, tuples are immutable, numbers are immutable as well. So there's as you can see, S is a set here, and it is declared using curly braces, and the type of S is set returned by the Python interpreter. And as you can see, we have just considered immutable values here. Numbers are immutable, tuples are immutable, strings are immutable as well. So this set consists only of immutable elements, and the type of set here is a set. The type of S here is set. So nextly, what if we put some mutable elements into it? We have already seen that lists are mutable. We can make changes to them without altering their value. So what if we put in a list in a set? As you can see, the type error is returned and we get an error that unhashable type list is put in as an element of the set. So remember to put in immutable values only in a set. Another interesting thing with sets is that sets only contain unique values. Even if you want to insert repeated values forcibly by putting in them again and again and again, a set will take a single element once only. You can see here we have repeated 3 twice, then there is this 2 again, this 1 again. But since they are iterable, we then print a set using the asterisk symbol and we just obtain 1, 2, 3, 4, 5, indicating that the elements which we had repeatedly inserted are not considered. Only one single original copy of each element is maintained in a set. They cannot be repeated. Now another thing here, that sets are not subscriptable. You cannot access them using indices. So if you do something like this, access a value of a set using an index, you will encounter an error here. So remember, sets are not subscriptable. Nextly, we see that sets are mutable. Although they contain immutable elements themselves, they are mutable. You can add or remove anything from a set without changing its ID value. We have added 100, there is this set here. We have also removed 5 here without any errors. Pop is also the same. Remove is used to remove the specific element. Pop is used to remove the first element in the set. As you can see, 1 is removed and we obtain 2, 3, 400 here. Now, there are interesting functions related to sets which you must have come across in algebra, namely union, intersection is a superset, a subset, set difference. So these are also available as functions in Python. Suppose you want the union of two sets, then you can write s1.union, and as you can see, each element of each set is printed only once and the resultant huge set is obtained. Intersection just prints the elements which are present in both the sets. Remember, there are no repetitions in any cases since sets themselves don't contain repeated elements. So we can also check if one element is a subset of another. Here we want to check if S1 is a subset of S2. Clearly it is not. S1 contains many elements which are not present in S2. For example, 3, 5, etc. We can also check if one set is a superset of the another set. Clearly, S1 is not a superset of S2 as well since S1 does not contain 10. If we find the difference between S2 and S1, 10 is obtained, saying that S1 cannot be the superset of S2. We can also check if two sets are entirely different, that they have no elements in common using the is-disjoint function. S1 and S2 have common elements here using the intersection function. We have already seen that they have 1 and 2 in common, so they are not disjoint. So false is returned as the result. Lastly, we come into dictionary. Now, dictionary is a collection of key and value pairs. Each key is assigned a particular value and it is formed as a dictionary. In dictionary as well, you see words and their specific meanings assigned to them. Dictionary is quite similar. So we have seen that this is a set, right? Anything declared within curly braces is a set. Now dictionaries are also declared using curly braces. So how do we differentiate them? The thing here is you have to mention a value to each key in the dictionary using a colon. You can separate the key value pairs using commas, but to assign a value to a key, you need to use the colon operator. And then if you check the value of D, then dict is obtained, indicating that the type of D is a dictionary. Now, dictionaries are not subscriptable, so they don't support indexing. Suppose you want to find the value of the first index, then you cannot do so by just writing d of 0. You need to access them by using the key values. We have the key value here as NITR and the value is Rarkela. So if you put in NITR as the index, then Rarkela, which is the value of that particular key, is returned. Now, what if that key is not present in the dictionary? Then naturally it will return an error. Suppose you want to find out IITB, then it is not present, right? So here you can assign a particular key value in this way as well. You don't need to mention it within curly braces always. You can just put in the key value inside the square braces and then you can assign the value you want to by using an equal to operator. So the dictionary now becomes this with two keys and two values assigned to each of them. Now we can also check the length of a dictionary using the len function, and since there are two key value pairs here, the output is obtained as 2. In order to check all the keys in a dictionary, you can use the d.keys here. NITR and IITB are the two keys, so we obtain the output as 2 keys here. Then to check the values here, you can use the d.values and Rarkela and Mumbai are obtained as the values here. Now in order to check both the key value pairs, you can use d.items. And NITR and Rarkela is a key value pair, so you obtain one output, and IITB and Mumbai is another here, so you obtain another output. So keys for keys, values for values, and items for both key value pairs. Now, if you traverse a dictionary using the asterisk symbol, it won't return an error. But remember, it will just return the keys in that case. If you want both the key value pairs, then you need to traverse the items here. By default, if you just traverse the dictionary, it will always return just the keys. Now, if you want to make changes to any value of a particular key, then you can use the update function, for example, and then you pass in the key value, which is IITB here, and you assign the required value there. So the resultant dictionary now changes, and IITB has a value of assigned to Bombay to it, and no more Mumbai. You can also delete something from a dictionary. Suppose you explicitly pass on the key value here, then that value is deleted, indicating that the dictionary D no more has IITB key and the value deleted here is Mumbai. So what if we have performed many operations on sets, lists, strings, but remember you cannot do these with dictionaries. You just can't add two dictionaries. Suppose you make another dictionary, namely Odisha as to India, and then add them, and then there will be an error here. You can learn more about dictionaries and lists, sets, tuples, strings. There are innumerable concepts regarding that. You can explore the internet, go to W3 schools, and then learn more about them. So this is where we end today's session here. Hope you liked it. Thanks.